Hi all, good morning, good afternoon, and good evening. Today we'll discuss about Hbase. Okay, we'll discuss about Hbase. As in our last class, we have discussed about the Flume, how to collect the live data, like how to harvest the data from the live sources, like log. We have taken the log from the Apache server, like HTTP server, or you can say it is a web server. The logs are dumped in real-time basis by the Flume agent. So today we'll discuss about the Hbase. So why Hbase came into the picture? We'll discuss why it is required. So Hbase is a NoSQL database. Okay, NoSQL means not only SQL database. So it can accept structure, unstructured, all kind of data it can be accepting. Okay, this is the NoSQL means not only SQL database. So by this component, by this ecosystem, there are many, you know, problem statement can be solved because it can accept the unstructured, I mean semi-structured and unstructured data as well. Because our RDBMS, our traditional database systems, they can only cope up, they can only deal with the structured data, but there is no way to deal with the unstructured data. So for that reason, the HBase came into the picture. So firstly, like Google Big Table is there. Based on that Google Big Table, the HBase also implemented all of the features of the Google Big Table, and we'll discuss all those things. So the first point, why we'll go for the NoSQL database in the sense, first point is RDBMS don't scale. Means I have purchased one RDBMS system. Means I have configured one system. It is a hi-fi, or you can say it's a enterprise class hardware. Means very high reliable hardware I have purchased. So this is the hardware. Okay, this is the RDBMS. So MySQL you can say, okay, or any RDBMS system means relational database management system. So this system having like hard disk, HDD, few components I'm talking about, CPU, RAM, MB, motherboard. Okay, in motherboard all those components are there. So just I'm specifying with the space, processing, and temporary memory. So this is the my RDBMS system. So the first point here it is mentioning that RDBMS don't scale, even though like suppose, okay, so there are, I mean it is in the production, so it can sustain many users. Suppose 1000 or to 1 lakh users can be can be access to this database, and it is well and good. So when beyond 1 lakh users are accessing this RDB it cannot sustain, it cannot give that much of performance. Means sometimes people are keep on saying that okay, this is giving some problem in the sense like performance issue, or it cannot handle that much of traffics, that many of requests it cannot be handled, it is giving some problems. So for that reason what it will do is it can some extent we can solve the problem by increasing the configuration. Okay, by increasing our configuration we extend something like maybe hard disk I can increase some extent. Suppose it was 1 TB, after that I can enhanced by attaching some of the disks. 2 TB I can made it. Okay, the same way in the motherboard also it has some capacity, I can put one CPU, again more CPU also I can put, and RAM also I can upgrade. Okay, so this is my limitation. Okay, I cannot go beyond that limit. I have added already excuse me, I have added all the components which is the maximum limit, I cannot go beyond that. Okay, so that type of scaling you can say is a vertical scaling. Okay, this vertical. So some extent it can be extended. Okay, it can be extended, but beyond certain limit, up to this limit, they cannot go beyond. So for that, that is also one reason to come up with the Hbase. Means Hbase also one kind of database. It can accept all kind of data. It can accept, but here only the structured data can be handled. So that is also one reason. So these RDBs don't scale. It cannot be scaled like that. But if you go for the Hbase, because Hbase is sitting up upon the HDFS file system only. Okay, we can say the storage part is like HBase storage also depends upon the Hadoop distributed file system HDFS. So it is scalable. Just go ahead and add the systems and the fly. That way, that is also one point and hard to share. Okay, so this data cannot be only using for a single purpose, not different purposes. But in if you put the data inside the uh, like HDFS file system, it can be utilized with the multiple ways. That is also there. Specialized hardware and expensive. So it is not possible here. So here specialized hardware and expensive. This commodity, this hardware is very expensive. It is an enterprise class hardware. It is an enterprise class hardware. Class hardware. In the sense what? It is made by Dell, HP, etc. Okay, they are specialized. This hardware is very specialized hardware. Okay, it has like dual power, like two power supplies, and hard disks, like a bunch of hard disks you can attach to this system, and it has minimum of 128 GB of RAM. CPU also 16 core, 32 cores, like that. So it is a very hi-fi system. It will not frequently go for the reboot, or it will not give that much of problem. Okay, that type of hardware, that is called enterprise class hardware. So this is very expensive. This cost is minimum, like if you go for the minimum of configuration, we can have like 5 lakhs or 2 lakh 3 lakhs, more than 5 lakhs, like that the device cost. But if you go for the Hadoop implementation, we can have, you can attach your desktop also, it is fine, well and good. Okay, we can go ahead with the commodity of hardwares. So that is the another point we can go ahead with from the RDBMS to NoSQL. But HBase is not a replacement tool, because some of the problem statement, if your users are less or the traffic is very less, it is well and good in the RDBMS. So that's why we cannot say it is a HBase is a replacement tool. It is coexisted. And Google Big Table. Okay, Google Big Table, what it does, this has all the features. It is completely taking this feature and implemented in the HBase system. Okay, so the first point, what is that, we'll discuss. So it is a distributed multi-level map. Distributed multi-level map in the sense, it is a distributed file system, means all the data will be distributed across different nodes. So the Headspace also we can have number of slave machines. Okay, number of slave machines. Suppose if you integrate with the HDFS file system, I can have all the data nodes that we can make as a slave machines. So the data will be across all the nodes or multiple of nodes. So it is a distributed multi-label map. So map is not like Google Map or something like that. Map in the sense, the data would be stored in a table based of key comma value. When the Mapreduce program is there, we already little bit introduction, I mean we have discussed like how the data is storing, like it is key comma value. Key in the sense, like maybe some element, and irrespective of that element we can have some value. So key comma value is called a multi-level map. So the data would be stored in a key comma value. Means the, suppose the name of a employee, and what is the value, means what is his salary. This employee belongs to how much he is getting, means the salary. Employee is the key, and values are like age, salary, location, department, all those things are, you can say, a value for the employee. So like that, that way it will be stored there. So it is called a distributed multi-level map. Okay, and fault tolerant persistent. Fault tolerant in the sense I have like multiple of nodes to form a cluster. The same Headspace also it it have it has like a lot many systems. Like it depends upon the HDFS as a storage. So all the data nodes or all the systems combine to form a fault tolerant because the replication factor I set as a 3 but that is the by default. So that way if one system goes down I can have two more copies, if another system goes down I can have one more copy, and in between the replication factor of 3. So at any moment of time it can replicate. If one node goes down, the same copy or same blocks which is stored in that particular data node, it will be replicated to other data nodes. So every time the condition, the replication factor 3 is satisfied, means I can have my 3 copies at any point of time. So that is called fault tolerant. So the same thing here also it is implemented, and it is a persistent. Persistent in the sense it is a storage. So it is not a temporary storage, it is a permanent storage, because what the data we are storing in the HDFS file system, it is a permanent one. Okay, it is not a temporary. It is not a temporary data. It is a permanent. That is called persistent. And scalable. If you wanted to scale the systems, like suppose the Hbase is there, so and I have collected lot many information, lot of data, but suppose I have 5 TB of space is there in that particular cluster. So if I wanted to increase, because my data I analyzed my data will be grow like beyond 5 TB, so what I'll do just on the fly I can go ahead and add the systems. So that way the scalability is also applicable here. So it will be automatically, I mean if you add the systems automatically it will be scalable. So the scalable solution also there on the fly without any problem, without disturbing the existing cluster, without disturbing the processing storing, I can add the system. So that is called scalability. Okay, this is also one point. And runs on the commodity hardware. So no need to go ahead with the no need to go ahead with the enterprise class of hardware. So expenditure, the upfront investment also little bit less if you compare with the commodity hardware, because commodity hardware is the hardware which can specialized. We can order to the hardware vendor saying that okay I need the hardware but the pricing should be very less. So that way they will manufacture to that storages. Nobody will be commodity hardware in the sense you can take your laptop also as a commodity hardware, but nobody is in the production, nobody will be involved their laptops, but they can order to the company for the specialized hardware, so that they'll build on that way. Like you know pricing basis it would be very less if you compare with the enterprise class hardware. And self managing in the sense like it is a self-healing. So as we discussed, if my one data node goes down, okay, if one data node goes down or any name node or any second name node goes down, the cluster is built in such a way that all the things will be managed its own self. When one data node goes down, all the blocks will be replicated to another data node. So we are not doing intentionally, okay, we are manually, we are not doing all those things. Automatically it will be replicating the data, and the block report and the replication under replicated block can be solved by by replicating or by adding one more storage or one more data node. So that type of mechanism, the replication factor and the movement of the data blocks and maintaining 3 copies in any moment of time, all those things can be happen internally. Okay, we are not doing all those things. So that is called self-managing or self-healing. The replication factor or other things can be happen it's a own. We are not doing manually all those things. So that is called framework is doing. So this is called self-managing or self-healing. Large number of read and writes. So because in a table, in a database, we can have 1,000 or 1 lakh or 2 lakhs of records. Okay, that record is a very huge. So larger number of read and write operations can be happen in the databases. So in the big table, in the Google Big Table, also all those features are intact. So all those things are already replicated or they can be copied to the Headspace system as well. So to deal with that, the Headspace also capable of that because it can handle lot many read and write operations. Because I can have 1000 and more than 1000 or 1 lakh or how many records you wanted to keep in the table, it would be there. First scans. So first scans, how it would be possible if compare with the database. Suppose this is your database. Okay. So in this database, I can have in it is ADBMS. Okay. So employee name, okay, employee name, salary, age, department, MP ID. Okay, there are lot many things are there. Sham 200, age 23, department IT, and employee 100. Like this, suppose there are this many of records. There are 1000 of records are there. Okay, suppose huge records are there. I'm taking here the same example. There is no problem. Okay, so this many data are there in the RDBMS system. Suppose you wanted to fetch the information. If you wanted to fetch the information, employee name, okay, only employee name and employee name and the age. Okay, you wanted to age. You wanted to extract. You wanted to make a query against this big table, against this database with employee name and age. I wanted to extract employee name and age. So what will happen when we made a query in database in the RDBMS? It will be go through the complete record. Okay, it will go through all the records and it will search the employee name and employee age, and it will fetch to the as a output to the end user. Okay, by the query. So on the fly, on the way, it will search entire record. All the records will be searched, but in case of Hbase, what it will do, I have like I need employee name and age. So what it will do in the Hbase, it will go to the employee name and employee age and it will fetch the data. Okay, so only the two queries will happen. It will not go through all the records. It is not going to query all the records. It will not search for the entire record of the table and it cannot fetch the data. But RDBMS it will take long time because it will be read all the records and it will fetch out of two records. Okay, out of all it will fetch two records. But in Hbase, what it will do, how many record you wanted to fetch, how many records you wanted to read, it will go to that record and it can read. So that is the beauty of Hbase. So that's way it is faster scans. It will scan very faster if you compare with the other databases. So that is the point here. And another point is open source big table. Okay, so this big table or Hbase, okay, it depends upon the big table concepts. So it is a open source. It is a open source in the sense you can download freely. Okay, that is the thing. And HDFS aids underlying DFS. HDFS aids underlying DFS, distributed file system. So the Hbase also what it will do, just it is directly sitting upon the HDFS file system. It will not do any kind of Mapreduce. It is something different. Different in the sense like it is upon the HDFS file system. Excuse me. If you go ahead with peak and hype, what will happen? The peak source code and hype source code will be converted into Mapreduce programs. And after that, it will be converting from the peak and hype to Mapreduce program and it is executing. But here it is not like that. The HBase is not going to convert into Mapreduce program and it will be not fetch the data. It is directly interacting with the HDFS layer because it is directly sitting upon the HDFS file system. But the HBase file system or HBase data can be as an input to the Mapreduce program. That is also there, but it cannot convert it into the Mapreduce program and it cannot go for the other processing things. It will not process by converting the code into Mapreduce. It is directly interacting with the data which is there in the HDFS file system. And Zookeeper is a log service. So Zookeeper is a component which is a coordination service. It will coordinate with all the client machines and it can coordinate with all the client machines and it can take the decision or it can give the information to the master machine. That will discuss further. Tight integration with the Hadoop MapReduce. So what does it mean? Tight integration with MapReduce. Hadoop MapReduce means it is not going to convert the HBase code or HBase data cannot be converted into MapReduce program and for the processing. It will not do that. It is directly sitting in the HDFS file system, the data, because we are pulling the data as a table from the external sources, or we can create the data and it can put in the HDFS file system. But that same data which is there in the HDFS file system can be integrated with the Mapreduce program. It can be used as a hive, as a peak. Also, that data can be utilized by other components and it can be converted into the Mapreduce program for other components. But it is not converting the HBase data into the Mapreduce program to process. So that is the point here. This is the HBase some points. HBase never use Mapreduce program because this HBase is a very complex component in the Hadoop ecosystem. You can say there are dedicated administrators are deployed for the HBase administration because it is also one complex component. Means you can make the same setup, the Hadoop setup how you have done like data node, name node, master machine, slave machine, all those things. The same way also there is a concept like of there is a master machine, slave machine, all those things are can be doing a HBase setup we can make. So it is a complex component we are seeing. So HBase, what are the points we will discuss? HBase never use Mapreduce program for this programming. So the same thing already we discussed. It is not going to convert the HBase data cannot be converted into the Mapreduce program. It will not utilize the Mapreduce program and it cannot process further. It is directly process by using its own mechanism. Means like the table structure, the column family database. It is a common column family database and we'll discuss one by one. HBase is good, but not the replacement for the RDBMS and HDFS. Already we discussed the same point. It is not a replacement tool because RDBMS functionality is different than the HBase or HBase. RDBMS also some extent like certain limitation. It is very well and good. So it is not a replacement tool. It will be working as it is because we some things we cannot do in the HBase system which is RDBMS can do. So RDBMS some extent it is very well and good. Okay, so that's why HBase is not a replacement tool. Hbase is a regular database and cannot use regular SQL queries. The Hbase regular in database means Hbase is not like a regular database. Like we have like SQL database, RDBMs, like Oracle database, all those things. The same kind of interface we cannot get in the Hbase. Okay, because Hbase is developed by coding with Java. Okay, and this database is something different. Database have the database interface to access, to interact with the databases, but Hbase having its own interface to interact with the Hbase database. Hbase is designed for a low latency. Why? Because Hbase has a scalability, fault tolerant, all those features are intact with the Hbase. This is a very huge system, means the horizontal scalability is also there, but in place of rdbms there is only one solution, like vertical scaling is possible. There is no horizontal scaling kind of thing. Even though if you have a high availability like HFR, only two systems can make it a HA cluster. But beyond that, we cannot do it. So that's why there is no horizontal scalability. Only the vertical scalability is there. So that is also some limitations. Beyond that, we cannot do it. So for that, we can set HBase is a design for a low latency, because the HBase query, the HBase query can be distributed across many nodes because the data is spread with multiple of systems. So while fetching, while doing all those things, the processing, while searching, while forming that table, all those things, there are many systems will work in the background. That's why HBase is very low latency. Low latency is when you fetch the data, it will take very less time if you compare with the RDBM system. Headspace is for random access data and not for a sequential manner. What does it mean? Suppose I have the data. Okay, I have the data. Okay, here data is there, and so this is the some kind of data. Okay, this is some kind of data, different data types. So random access in the sense it will be choose randomly. Okay, it will choose sometimes while reading the data, what will happen, it will may choose this data, like maybe this one. Okay, after that maybe this one, after that this one, or after that this one, like that it will be choosing while reading and writing the data, it will be choose like this. Okay, so this type of access we can say is a random access because there is no pattern to access. But while if you go for the sequential access, okay, if you go for the sequential access, what will happen, the sequential access is like this. The sequential access is this way. Okay, like this, one after another, like serially. Here you are watching YouTube. Okay, you are watching YouTube, means one by one, one after another, one after another, one after another, like the sequence. So while accessing the sequence data will take very less time to access. Very quickly the IOPS, input output system of the sequential access, is very faster. But while coming into the random access, because the data is spreading here and there, I can access, there is no sequence, there is no order. So first I can pick this one, after that this one, after that this one, and after that this one. So this is called random access, and this is called sequential access, means one after another. It is in order fashion. It is in unorder. There is no order of the data. Okay. So this way The Headspace is random access data, is for random access data. So Headspace is completely fit for the random access data also. There is no problem at all, but not in a sequential manner, because the live data and unstructured data, structured data, all those things can be handled by the Headspace. So it is very fit, big fit for the random access data. So random access data is always very huge size. It is very huge size, and this one little bit less size, because it is called a structure. You can say it is a unstructured data. So structured data can be fit for the traditional databases, RDBMS. Headspace data model. Headspace data model, like, it is like a key comma, like, column family oriented. So how, I'll tell you. The columns, it can be, multiple of columns. I can combine multiple of columns. I can combine to form a common column family. Okay, that way I have to represent the data because it is a column family database. So that is called the data model of the Headspace. And sparse table and dense table. So what is sparse table? So it can, it's fit for that sparse table as well. Suppose this is the table. Okay, this is the table. John, USA, then time and 300. Try measure and city file 5000. So this is called as, this is like one table. Suppose this is one table. Okay, this is one table. So this type of table we can say it is a sparse table. Okay, it is a sparse table. It is not the dense table. Dense table in the sense it has the format. There is no null value. Okay, here see one value I can get it. Okay, out of this table I can have one value here, and there is nothing. It is a null, and this is USA or something like that. You can say something is there, some element, some record is there. Here nothing. This is called null value. Okay, this is null value, and this is the value. This is the value. This is the value. This is the value, and there are lot many empty columns are there, empty elements are there, or empty records are there. You can say this is the one record, like that. So all the records are, most of the records are empty. You can say it is a null. So that can be processed. That can be processed with the Hbase, but the null value cannot be processed in the RDBMS file system. If you are from the database background, you very well know that this one. Okay, so this is called sparse table. And dense table in the sense, like, I can have all the fields are fulfilled, all the fields are filled with all the value. So that is called dense table. So it is more comfortable with the sparse table, means it can accept the Hbase can accept the sparse table, it can accept the null value as well. So that is the beauty of Hbase. And advanced table, this is the example. See, this is the employee table. In that employee table, what is the elements? One is employee ID and another is employee name. So I can have the employee ID 100, 200, 300 and respective names. The same here also, the employee department, employee ID and employee department, the ID with the department. And this is another table. I can have employee ID and marks it and 10th mark and 12th mark. So all are in the RDBMS database tables. But if you go for the NoSQL database, NoSQL table or HBase table, we can have something like this. See, employee ID, employee name, employee department, employee location, and all those things. So entire thing like one table. But here I can have different table, the same data I can make it. So RDBMS, but NoSQL table is like one column family. Okay, so it is like combined to form one table, and it can accept the null value. But here it is not taken the example, and this is the sparse table. I'll tell you how it is, how it looks like, the keys and values. I'll tell you this one, okay, how it would be the sparse table. Suppose here you can say the record or the row, you can say it is a 1, 2, 3, 4 like that. So I can count from 28. Yeah, thank you. So the NoSQL table, how it looks like, we'll see. It's a demo. We'll see. So it is called a column family database. So how it would be? Suppose if I'll take another sheet, it will be good. This is one example. Okay, I wanted to start from one. Okay, so this is one table. So it is a column family database. So this data, how can I represent in a Hbase table? Suppose this is one row. We can say row 2, 3, 4, 5, 6, 7, 8, 9, like that. Rows are there. Okay, here I can also put some data. Okay, possible. And, okay, here also. Okay, okay, here something can put. Okay, so that data, suppose this is one row. Okay, this is one column. So you can say it is a one row. Okay, it is not a row oriented. This is the record. You can say one, and the column is, what is the column name? It is a column. A. Then what is the value? John. Okay, the value is John. Okay, and this is the A, right? This is the column A. Okay, so this is the record one. Okay, one, I have taken A John. Then C USA, same one, C USA. Okay, and the record one with time, or like that. What is there? I have to take H time. Okay, and coming to this one, it is A. So there is no record in the row two. It is empty one. So three, I can take it. Three, third record with A, 3000, 3000, record 3, E, 3, E, then what is that? Salary, and H, third record only, H, column is H, Azure, okay, and coming to this one, it is a fourth, right? Fourth record with C is the column, and value is 33. Like this, I can represent the table. Okay, so I think you are following me what I'm doing. The, there is no empty table. Sixth is the record, sixth, and A is the column. Value is CT, CI, TI, CT, and file also it will be sixth. D is the column. D is the column, and file. So this way, like this, it will be happen and so on. Okay, so all this table data, the complete table data, I can represent in a single column. Okay, in a single column I can represent. So this is called column family oriented database. Okay, this way it will be represent. See, the same thing, same meaning it is presenting, right? This way, if I spread like this also fine, but the HBase will be, can be read and write this way, like column family database. That's why it can say, it can, we can say it is a column family database. Is there any doubt here? What I've represented, the same thing, right? A, one record in the first row, we can say first row. What is the what is the data? A John, A in the first column, and in the sixth column USA, and the H I can have one value like time. I can represent in a single column. This is the one row. All the row oriented row data I can represent in a single. This row, this row, this row, this row, this row, all the data can be represented in a single column. So that is called column family database. This way the data can be represented in the Hbase. Okay, so this is the difference. Here it is combined all the things in a single table represent, but here I can represent single single table as well as the separate tables. So this is the structure. This is the structure of the Hbase table. As an administrator, actually it is not required to discuss all those things, but thing is that I wanted to explain you something like, so that it will feel comfortable, like okay, this is the way it is happening, the data structure is like this is the architecture is like this. So that way we can, as an administrator, we have to facilitate the infrastructure. So if you make the system get ready by installing the Hbase, and you can do the setup of the architectural setup. If you provide the same thing hand over to the management, it is well and good. But if you knows how to works, what is the tabular format, I mean how what is the how the database looks like, how to works, if you knows all those things, it is very well and good. Okay, if you have no idea at all also, there is no problem. That is the point here to discuss. So this is the table, this is the sparse table, means this is, it can accept, because this Hbase database Hbase can accept the null values as well, but in place of rdbeams it cannot accept. We have to put some value here, then it can accept the table. Okay, so there are the history also, history is there, how it is evolved. Like big table is like Google's big table. Okay, Google has given lot many ideas. Google has lot many contribution towards the big data industry, because the GFS, Google File System, is also the contribution for the HDFS file system. This is the due to the Google File System, the HDFS is now, you know, it is the main contributor, you can say, due to the Google's white paper. They have implemented the same thing in the Hadoop industry as well. So in 2006, the big table was there. Big table, what does it mean? Means it is searching the Google Map and the Google Mails. All those things can be in a tabular format. So that way they have developed the big table things, and they can segregate. So how many like map location also, you can say it is a key, and what is the value, location, how many distance it is. So you can take any value. Okay, for that way they are the search, they will do the searching or indexing kind of thing they will do. So that way they implemented the big table. All the big table things can be replicated to, or can we can copy it into the Hbase table, Hbase database as well. In 2007 it was contributed to the Hadoop, and it was a sub project of the Hadoop that time. In 2018 it is a sub project, which is the Hbase is a sub project for the Hadoop. And after that in 2010 it is the topmost project in the Apache Foundation, in the Hadoop level. Why? Because they realized the Hbase can solve many things. And 2011 it got released as a 0.92 version, because in the middle we can have a lot many testing, all those things, all the features are all the features are working properly or not, all those things they are doing. So at last they can released in 2011 the Hbase. So Hbase is a very vital role in the all the big companies they adapted, like Facebook, Google, all those things, because it can easily identify, it can easily, they can analyze the unstructured data. Okay, there all the data, unstructured data can be processed, can process in the sense like is a database kind of thing, like query, we can have lot many things, it can be solved. So that is very important thing in the Hbase database, because it can accept unstructured data as well, and it is a common column family oriented database. We'll discuss the same thing. So this is the NoSQL database, how it is like Hbase. So there is the component, already we discussed the HDFS, and upon that we can have Mapreduce, And upon that have we can have lot many ecosystems. So Pig and Hive, what it'll do is they can convert their code into the Mapreduce, and Mapreduce program is again further processed, like processing will happen with the Mapreduce program only. Pig, we can develop our code with Pig, but that can be converted, and the actual data will be stored in the HDFS file system. Upon that, the processing will be happen by the Mapreduce program. But while coming into the Headspace, Headspace is there is no Mapreduce program linking into the Headspace. Headspace is directly interacting with the HDFS file system. Means the data, the whatever the data is putting in the HDFS file system, that can be processed directly by the Headspace. And this data, the Headspace tables data, can be easy input to the Mapreduce program as well. I can do some other analysis by utilizing the data. So that is the point here. So the Mapreduce, what it will be, how it will be executing, like it is a sequential access. It is a sequential execution. Means one after the another, it will be executing one by one. But while coming into the HBase, it can execute, means it can pull the required amount of data in the middle as well. Okay, already we discussed. So it will not going through all the records. It will not going through all the records, and it cannot be like sequential access, sequential execution. It is a random execution. So if I need two records out of my big table, I can fetch two tables. But while coming to the RDBMS, it can search all the way to fetch the two tables of the data, two elements of the data, or two records it can fetch. So it will take longer time. So this way it will happen. And Hadoop HDFS file system is the contribution by the Google, like GFS white paper. By that way, they have developed HDFS file system is equivalent to GFS in the Google. Okay, and Google Mapreduce also contributed to the Hadoop. The Google, before it was used by the Google, the Mapreduce, the same thing is implemented or integrated with Hadoop as well. And Google's big table is the main foundation of the Headspace as well. Okay, and I have taken the example. This is the sparse table already we discussed. This is the points. There are lot many null values are there, and the column family oriented data can be represented by the HBase. How it is the same thing. Like this is the first record. Okay, first record here A Siva, and F is the 5000, like this it is. So it is a column oriented column family database. In a single column I can represent the entire data. So that is the thing. So first is row key. Okay, the rows, this is the first row. What is the key? The key is 1. The first row key is 1. The same thing we have discussed. The first row key is 1, and this is the value. First row keys. So this is the called key comma value. So that way the key comma value it can be represented. Okay, this can be represented in the key comma value. In a single column, it is complete data can be represented. And column name. So this is the column name is A, B, C, D. Where the value is there, I have mentioned here. Where there is no value, it is called a null value. It can be accepted by the Headspace. So Siva is the one record, and it is belongs to A column. And F is another column. It is the value is 5000. The second column, second row, I have the two value. Okay, means row key. Rows key means key is a value that is equal to here, and um, the element, the value name is HUID. And the third, in the third row, the value row key value is like 3, and D for Ramesh. Here it is mentioned. So this way, like row key, column name, and value. It's value. Row is the key. Okay, it is a key, row key, and key comma value. So key is the row here, and value is the value of the element column name. Okay, so this way it can be represented. Same thing, this is the history. Same history I have represented, and this is the storage mechanism in Headspace. How it is happening? So there is a row ID. Okay, row ID is for entire row. There is a ID. It will be generating like 1, 2, 3, 4 in this year. And column family. So I can take in three columns here: column 0, column 1, and column 3. So all this column 3 I can combine to form a column family 1. And same thing, I can combine multiple of columns. I can make a column family 2 and column family 3. So this is the storage of the Hbase column family database. This state will be stored. This is the storage mechanism of Hbase. But if you go for the RDBMS, it can have all the values separately. Okay, and this way it can be represented. There's a small difference between the Hbase and the RDBMS. Early, I think we have discussed, but little bit we'll discuss again. Column oriented and RDBMS is row oriented. Here only in a single column I can represent my entire data, but in RDBMS I can have to have column as well as the row. So row is very important role. So that is called row oriented data. In Headspace, flexible schema add columns on the fly. So while reading and writing in the Headspace, there is a flexible schema, means we can alter, we can change the column or the value of that column, we can change, okay, on the fly. But in the RDBMS, it is a fixed schema. We cannot change once it will be loaded, once it has been created, the schema cannot be changed. We have to have enter the same type of value to that record. Okay, so there is a fixed schema is already there, but in the fly I can change in the Hbase. Good with the sparse tables, because in the Hbase it can have sparse tables, means it can accept the null value, but here not optimized for the sparse table. It is not optimized, it is not a good output we cannot get in the RDBMS file system. Joins using MR not optimized. Here joins is very difficult in the Hbase. There are 5 tables that cannot be joined. It is very difficult. You can take some other component as well, because Hive you can take it and you can make it the joint. Again you can dump into the, or you can put in the HDFS file system that can be fetched by the Hbase. But directly joining is very difficult in the Hbase. But in RDBMS the joins are very easy. Like there are 5 tables I can join, and I can combine to all the tables and combine to form the one table as well. So joins are very easy for the RDBMS. Tight integration with MR, and not really, because tight integration in the sense all the data which is there for the Hbase data can be input to the Mapreduce program by other ecosystem. It can be utilized, so that can be integrated with the Mapreduce, we can say. But here it is not like that in RDBMS. Horizontal scalability, just add hardware. In horizontal scalability is there in the Hbase system, because it follows the same rule in the HDFS file system. So scalability is not a problem. Horizontal scalability can be happen on the fly without disturbing the cluster. I can add the system how much I want it, but it is hard to set and scale. In the RDBMS, it is very difficult, because only the vertical scaling is possible, and that is also some extent. Not beyond, I cannot go ahead. Good for semi-structured data as well as the structured data. So Hbase can accept semi-structured and structured data very easily. It can cope up. It can give very good result. But in RDBMS, only the good data, only the structured data can be as an input or can be handled properly. And some of the use cases where I'm going to use the Hbase, it is unstructured data. Okay, the first point already we discussed, high scalable. It is scalability is there. Already we discussed the same thing. And version data. So in Hbase I can have versioning of the data. Suppose I have the record, okay, key comma value, or the family column family oriented data. With the data having the versions, I can keep by default 3 versions of the data, but in RDBMS it is not there. Okay, so that is the use cases. Like I can have the data of 3 versions. Suppose I have a data, okay, I have modified that data again, so that is another version. If I again modified with that another data, the same data with I have modified again, so that is the third. So third time I have modified, so the 3 versions of data can be intact, can be stored in the HBase file system. In the Hbase I can have 3 copies, not 3 copies, the modified data in a 3 versions. Version 1, and I did some modification. Version 2, again I did some modification. Version 3. So these 3 versioning data can be stored in a Hbase, but in RDBMS it is not there. Generate data from an MR workflow. Gathering, generating the data from an so that MR data like Mapreduce program data output can be also stored in Hbase, and upon that also I can use, because the Mapreduce program data is like structure or an unstructured or semi-structured data. So that can be also cope up, that can be also is input, or that can be fetched by the Headspace file system. So column oriented data, that is, it is more into the column family oriented data. So the row has very less importance here. It is represented in the column family database. Now high volume data to be stored. So if I have like huge amount of data, so that is well and good for the HBase file system, because it directly sits upon the HDFS file system. So it can accept huge number of data, or huge amount of the data can be stored in the HBase. So it is very comfortable to work with the HBase with high volume of the data. So that is the point here. So this many use cases when to use, like at what scenario. But if you go for the RDBMS, there is certain limit of the data. It can process maybe 500 GB or 1 TB, not more than that. Or, or, or there is some limitations. But in HBase, there is no limitation, because it sits upon the HDFS file system. So if there is a huge amount of data, it is well and good to be processed by the HBase. When not to use HBase, this is the point. In which scenario we are not going to use the Headspace. If you use the Headspace, it is well and good. The first point, like thousands or millions of rows are there, that time we cannot go ahead with the Headspace. It will be work, but it is not that much of worthy, because that type of data, or that many of the millions of rows, or that can the thousands of records can be easily handled by the RDBMS. So why you will go for the Headspace? It is not required. So when the less the point is, when the less amount of data is there to be processed, to be processed by the data, any database related kind of thing, it can be fit for the RDBMS. Don't go for the HBase. So when less amount of data, you should not use the HBase. If you wanted to use, you can use it. There's no problem. But the point is here, if huge amount of data is there, you can go ahead with the HBase system. Lacks RDBMS commands. So the RDBMS command means RDBMS kind of command, kind of interface cannot be used in the HBase. HBase is its own language or its own interface. So that is lacking, because many people are keep on using RDBMS, so they may not be comfortable with the HBase in the initial days. But that is completely different. The point is here, the RDBMS interface is completely different than the HBase. When you have the hardware less than 5 data nodes, when replication factor is 3, when your hardware is very less than, means like 5 nodes are there, if you go with the RDBMS, there is a cluster also, like HAP, like two systems you can combine to form HAP RDBMS clustering. So here the point is, if there are very less nodes, don't go for, and replication factor is 3, don't go for the HBase file system. If your cluster has very more, and it can, because it can handle lot many data, like huge amount of data, it can be, it has the capabilities. If you are putting less amount of data, there is no use, because it can be handled easily by the RDBMS. So that's why if you have like huge amount of cluster data nodes, and the replication factor is 3, that time if you go ahead with the huge amount of data processing, then you can go for the HBase. If it is less than that, don't go for HBase. That is the point here, but you can very well do that. Headspace can be quite well stand alone on a laptop. Headspace can run quite well standalone on a laptop, but this should be considered as a development configuration only. So what is the point here? The note is, in a Headspace you can install, because upon the third point is saying that if you have a very less nodes or less data, don't go for the Headspace. But we can go ahead for the development purpose. Suppose if you wanted to do some query, some analysis, or some you wanted to fetch some output by using the Headspace, you can go ahead with a single system, because that is part of the development and testing. But if you go for the production, go ahead with the huge amount of data, or very high volume the data can be fit for the HBase. That is the point here. Okay, so this is all about the Hadoop introduction. It is an overview, and tomorrow we'll go further discussion on the HBase, and if possible we'll do the demo, like how to install, and how to execute some of the command, like how to create the table and how to fetch the table. and how to modify the table. All those things we'll discuss, and we'll wind off the Headspace session tomorrow, probably, if it will happen. Okay. So this is the overview. If as an administrator, is not required all those things, but if you have some knowledge, it is well and good. That is the point here. Okay. So, well, tomorrow I suppose I thought I'll finish up today the Headspace by installing and doing some demo kind of thing. But again, I thought of okay, why not? We'll go for further discussion, clarify some of the some of the concept we have discussed, so that it be you'll feel be a good okay at least some knowledge you have regarding the Headspace. That's the thing. But if you wanted to portray it as a Headspace administrator or Headspace developer, then we have to have very good knowledge on that. So this is just like one kind of path I'm showing you. So if you wanted to have your depth knowledge, you can go for the Headspace books, and you can have some PDFs. You can have the many things are there, many sources are there. You can you can read all those things, and you can have your depth knowledge on this. But as an administrator, if you know all those things a little bit, it's well and good. So anything from your end, please let me know, so that we'll discuss. Otherwise, we'll wind up the session here, and we'll see tomorrow in the same time. And guys, I'm so sorry. Due to lack of time, I'm not going to say that scoop and plume the demo video already. I think the locus has been shared, but the document I'm going to share you today. Today, otherwise tomorrow in Indian time, tomorrow morning. Anyhow, I'll send you so that you can do the demo. But already you have the video, but I'm going to forward you all those things. And apart from that, after 2 3 classes, I'll prepare the document like what are the command, the entire commands, all those things, and with some uh, course material like some of the books, the PDFs I have, I'll share you with all you guys. Okay, so that you can go for that, and you can collect the information. And what I've taught already, you go for the concept, Google it, fetch some information, and study well, so that definitely will get a very good opportunity regarding the Hadoop administration. And if some lacking is there, just you can browse up, because already I have showed you the path, but you have to enhance it. This is very little bit you can say, even though we have discussed lot many classes. I think if you ask someone, I think they are not taking this many of classes, but thoroughly we have taken many classes. But you have to build, you have to enhance your the same the kind of knowledge regarding different like subjects like the Headspace, Hadoop, Hadoop concepts, all those things like topic wise you have to discuss, you have to enhance your quality, so that it is good for you, and you can grab lot many opportunities. That is the point here. Okay, if you have anything, please let me know, and if nothing, we'll wind up the session here, and we'll meet tomorrow in the same time. Tomorrow we'll do the demo. Okay. Anything? Abdul, Karthik, Tejas, Tushar. Anything you want? Okay. Thank you. Bye bye. Thank you. Thank you. Bye bye. Have a good time. Yeah. Thank you. Bye bye. I have.